Hey, what is up, guys? Welcome back. Today we're going to be diving into the week 3 workbook. And again, this is without the notes, without notes coming beforehand. So it should be pretty interesting. And yeah, let's dive in. So I got it printed out here, but I'll pull this up for you guys and we can work through it. Okay, it's pretty easy. Starting out, just 0, 1. Negative 1, 0. 0, negative 1. Part B. Just 90. Oh. Okay. So when it gives the first, that's the vertex. It's a little weirdly worded, but that's the vertex. So 1, 0. Okay, so just start, yeah. Okay, got it. 0, 1, 90 degrees, 0, negative 1. Oh, radians. Pi over 2, pi, and 3 pi over 2. I just have that memorized, but I'm going to try to remember the radian formula equation, the arc length. Oh, actually, it's not asking that. Oh, it would just be the distance formula. That just gives me the radius. Okay, I'm going to look at this. Is there a way to calculate the measure just from the points without using arc tangent, arc cosine, and arc sine? I went to the office hours, at least for one of the TAs. I went to 2, but one of them had a dentist surgery and so wasn't able to speak. So I just saved the introduction for next time. But the first TA mentioned that we're not supposed to know arc tangent and arc cosine and arc sine yet. So, yeah. That's helpful when working through what they're thinking of asking and how we should view the problem. Yeah, I don't see any of our existing equations besides those arc equations helping to find theta in this case, because we don't know the arc length. So, okay. So I assume it's just, we're supposed to memorize it. Radian measure in decimal form. It says illustrate. It says illustrate, but it also says in decimal form. So I'm just going to write the radian measure. Pi over 2. So what's that? 1 point. pi is 3.28. So 3.28 divided by 2 is like 1.64? No, 1.69. Let's see if that matches up real quick. And I got just a calculator and a graphing calculator up on this screen that you guys can't see. Okay, so actually, just 6.28 divided by 4 could be one way. Got 1.57. I said 169. I said 3.28, which is pi, divided by 2. It's 1.64. Oh, but even then, maybe that's just the rounding error. 1.64 versus, what was it, 6.28 divided by 4. 1.57, so that's a difference of like 7.07. Let's just try a few more. Okay, 3.14 divided by 2. 1.57. Okay. Pi times 2. Gave me the full one divided by 4. 1.57. I can just convert pi over 2 to radians and see. Or, what? 6.28 I thought was. .57. So why is that? Okay. Well, I could just divide. So 1.57. And it's asking for 180. So just 3.28. Oh, 3.14. 270. Yeah, let's just do it this way. 3 pi divided by 2. 4.71. .01 at 90 like this. Okay. An architect will a skiing trail has a 1 kilometer radius. Skier started at position 10 ski counterclockwise. At the rest point, 0.5, 0.87. So half high, I would half this. This is describe what the value 0.5 represents and illustrate this measurement value on the axes from exercise 1. It's pretty much, it's right in the middle of the x-axis of the between 0 and 1 on the x. But 0.5 kilometers to the right. Illustrate this one. Okay. 0.5. I'll just put 0. Okay. Describe what the value 0.8 represents. 0.87 kilometers up from starting Y position, 0. Illustrate it. Just 0.87 would still be on the y-axis. So 0.87. Okay. Recall that the sine and cosine functions are defined as x equals cosine and y equals sine. Given that x, y is a point on the unit circle, and theta is the measure of that angle that subtends the arc between. Yep. Use the unit circle to generate a graph of y equals sine, where theta is the measure of the angle subtending the rotated inflatable values on your axis, and 8 points on your graph using the given points on the circle. Okay, so I think it just wants to emphasize how it's a different rate of change, and since it's sine, how at certain points it'll be faster, and how at some points it'll be slower. So I'm not going to draw that. What is the domain of the sine function? What is the range of the sine function? The domain, which is the x, since the angle is the input, it's 0 to 2 pi. Well, you can keep going, so I don't know if the if all angles 0 to infinity is the same as if you just put like 0 to infinity like you usually would for domain, but is it 0 included? Yes, so infinity. I guess I put 0 degrees. Okay, what is the range of the sine function? Given that it's, well, whatever its radius is, but range equals negative radius and includes that to positive radius. Also a bracket. As theta varies from pi over 2 to pi, how does the output of the sine function vary? Slowly at first, then fast. What's the concavity? I don't know what that means. It's the rate of change of a function's derivative. I thought this was pre-calc. Okay. Here we go. What's concavity in pre-calculus? The shape of the curve. An average rate. Okay, so it's sine function pi. It's concave down. Use the unit circle above to generate a graph of cosine. Okay, I'm chilling. I'll be writing a graph for that. This theta varies from 0 to pi over 2. How does cosine vary? Goes from 1 to 0. Goes from 1 to 0. Let's see. Slowly at first, then fast. Actually, using concavity, what I just learned. Concave down, increasing. Concave down, increasing. Okay. Instead of saying slowly at first, then fast, I can put concave down, decreasing. The second Arctic village. Oh, yeah. Second Arctic village maintained a circular cross-country ski trail. There's a 2.5. A skier instructor seeing from the position for 2.75 miles before. So that's arc. Arc length divided by radius is, well, arc length equals radius times theta. So divide radius, arc length divided by, it's just theta. And I guess specifically, the angle from the origin, essentially, I mean, the angle from the origin representing the arc length in a general manner. I'll follow that one up for the professor. Represents theta. The angle from the origin. Okay, determine the ordered pairs measured in radius lengths. Should have followed up on radius lengths. The ordered pair measured in radius lengths on the coordinate axes. That identifies the location where the skier rested. Radius lengths. So is radius lengths just radius divided by 2 pi? Let's see. The distance. Oh, it's giving me what radius is. Radius lengths. Radians are the constant of proportionality between an arc length and the radius length. I'll write that down and see what the professor says. I think he just means like the radius. Measured in radius lengths. Okay, so just divide. Divide 2.75 divided by 2.5. Oh. I have to find, okay. I have to find theta, which is s over radius, which is 2.75 over 2.5. $1.1. Yeah. Oh, that's interesting. Radians, is also radius lengths. Like, if it's measured in radius lengths, so like how many 2.5s is 2.75? So obviously just divide 2.75 by 2.5. That gives you 1.1. But the equation for theta is, s equals radius times theta, so just divide radius, so s divided by radius is theta. So it's interesting that radians radian measure is the same as radius lengths. Maybe that's why everyone's like, memorize the radians of a circle instead of the degrees. But okay, now that we have that, we do sine. Okay, turn into radians. We do sine of 1.1. We get 0.01. Okay, that looks more right. Okay, so sine of 1.1 radians equals 0.89. Cosine of 1.1 is 0.45. So it would be 0.45, 0.89 in radius lengths. Okay. I think, yeah. Okay. I'm going to make sure that's correct. What the professor. Turn the order pair measure in kilometers. So I feel like you can you do the same answer and then just multiply it by the radius. Let's try it, see if it makes sense. 0.45 times 2.5, 1.125. Close to the half point, which kind of looks like it is, but not exactly. All right, and then 0.89 times 2.5, 2.225. Since what sine gave are proportions. I mean, a percent of the. Yeah. Alright, we got 2.22 and what I put 0.45. 2. Okay. Skier then continued along the trail, traveling counterclockwise until they had traveled for a total of 10 kilometers. So 4 trips around, 4 stopping for another rest. Determine the ordered pair measured in radius lengths on the coordinate axis that identifies the location. I'll just make sure. Travel for a total. Okay, so it's, I don't know if they're saying, when they emphasize total, if they're saying from the beginning of question 4a, when he started at 2.50, which is, angle 0, are you saying he then went 10 kilometers in total? Or you're saying from his resting point, he went 10 kilometers total? Because if it's from the very beginning, it would not be the same answer. But if it was from here, if it was from here and then it was another 10, then it would just be right back there. But if it started here, but the 10 was supposed to start here, then it would also be a different one. Am I crazy, or are these really badly worded? I'm not trying to complain, I just want to see if I'm crazy. I just might be dumb. Maybe I'm not reading it right, and everyone else is like, yeah, it makes perfect sense. I'd be like, okay, might be in that situation, but it's like it could be more clear. I don't know, I'd be curious what you guys think. Continued along trail until he had traveled for a total, emphasized total, 10 kilometers before stopping for another rest. For a total. I'm going to assume it starts from here. So because of that, let's see, total. 1, 2.5, 5, 7.5, 10. Okay, so if he's starting here, then just minus 8.25, or no, 7.25. Yeah, 7.25. That's the answer, 7.25. So it's just, I feel like it's just back here. Measured in radius lengths on the coordinate axis. Okay. That is this location. I feel like it's just, okay. And since 2.5 divided by 2.5 is just 1, and 0 divided by 2.5 is just 0, just 1, 0. Measured in radius lengths, yeah. Because 2.5 divided by, okay, now it's measured in kilometers. So it's just 2.5, and then 0. We'll see if I'm thinking about that right. I'll ask the professor. Suppose that a second skier started skiing from the position 2.5. Second skier can ski clockwise for 5 kilometers. Clockwise for 5 kilometers before stopping for a rest. Oh, you know what? I might have messed up here. Oh, yeah. Thinking that just divide 10 by 2.5. Isn't it times 2 pi? What's circumference? Circumference is pi equals circumference divided by diameter. So pi times diameter is their circumference. Yeah, you know what, let's, just in case, let's go back here. Okay, so their circumference. Okay. Circumference equals pi times diameter. So in this case, its circumference equals pi times 2r, which is 5. Oh yeah, that's right looking. Not pi times 5, 2r, 2.5. 15. Yep, oops. I think I checked this. 15.70. That's the circumference. That's interesting. So yeah, he didn't even go the. Oh, that's looking like 1/3. That's interesting. I don't know what is up. My brain is just fried today. I cannot even think straight. I have the circumference. I could just divide the 10. It wouldn't give exactly 2/3, so. But I don't, maybe that wasn't. Let's do 5 by 2.75. This should not be giving me this much trouble. See, what could I do? I could just 15.70. So it says total. I'm assuming from here. So 15.70 minus 2.75. It's 12.95. So I assume that's the distance traveled from here. Okay. So I'm going to use the arc length equation to find theta, which is 4 radians. Now that I have theta, I could just do sine and cosine, I think. Did not think this would be this hard. Sine 4. Negative 0.75. negative 0.75. And cosine is 4. Negative 0.65. Yeah, I'm going to go with that answer. Then multiply these two. Times 2.5. Negative 1.63. Okay, sine 4 times 2.5. Negative 1.89. I will also check with this. The professor. Suppose that a second skier starts skiing from the position here and skied clockwise for 5 kilometers before stopping for a rest. Just realized I didn't do the timer, but we'll start it now. Yeah, probably same thing, but we know that angles are always measured in counterclockwise, and so my first thought is to represent this distance as negative. Yeah. So let's do let's do that. So negative 5 over the radius, which is 2.5, which is negative 2. Okay, and then we'll do the sine of negative 2 and the cosine of negative 2 to get sine negative 2 is negative 0.90. 0.90. Cosine is negative 0.41. Okay. So it's negative 0.41, negative 0.90. Oh, that's radius length. Okay, now measured in kilometers, just multiply by 2.5. Cosine times 2.5, negative 1.64. Sine of negative 2 times 2.5 is negative 2.27. Let's see if that makes sense. So, obviously the distance from 2.5 clockwise to here is not just 5 kilometers because it's curved. And so let's say it's let's say this value is just 2/3 of the way. Would that make sense? Negative 1 or somewhere around here. Negative 1, negative 2. It would make sense because we know it's probably past this point and into the third quadrant. Okay, and let's gut check B then. 10 kilometers. Alright, now what I can do, I can just find the arc length. Yeah, radius times theta. Okay, 2.5 times pi divided by 2. 3.92 is the arc length. So with the radius of 2.5 from here to here, the distance traveled is 3.92. And don't think that's in radius lengths. That would be weird. I feel like that's in kilometers. Okay. That's like 4. So this is 4. This is 8. So 10 would probably be somewhere here in the middle. And so B we have kind of similar to C's answer, negative 1.63. So negative x and a negative y. So probably looks good. Okay. Consider a coordinate system where the coordinate values of a point are measured in the number of radius lengths. What is the general form of an ordered pair expressed in number of radius lengths of any point on a circle that has a radius of r kilometers? And okay, so it's just asking me to I wonder if it wants it all in one, or if I can have 2. It says general. Let's write it out as 2, and then we can consolidate it. So 1 I wonder why it's helpful to have the coordinates and radius lengths as well. Okay, first you just find the theta, which is s over radius. Oh, it's already given you. Ordered values are measured as the number of radius lengths. What is the general form of an ordered pair? It's a radius of r comma. Oh, it already. So r times sine of theta gives you the y value, or cosine of theta, same thing, x value, but in the units given. And I think if you just keep it as sine, it will keep it as the radius lengths. What is the general form of an ordered pair? Any point radius r. I don't think you have to write r. You can just do, yeah, the x is just cosine of theta, comma, sine of theta. Well, that will be cut. Welcome back, guys. Sorry, I just had to cut something out. We'll just leave right where we left off. We're just doing this. Okay. We're just seeing if you have to multiply by radius lengths, or if you can just keep it as cosine theta, sine of theta for the x and y. So going back actually to this example, let's just test that out. So, look, like right here, clockwise. What did I do? I did cosine of first. Well, I wasn't given theta. That's the thing. I was just given the arc length and the radius. But once I solved for theta, -5 divided by 2.5, -2. I had my radians for a pair measured in radius lengths. Radius lengths. Oh, yeah, that distance. I said 1.04. So I said -0.41. These are proportions. This is saying, oh. Okay, actually, maybe that would make sense. 0.41. Because 1 of a radius length is the 4 points. So obviously, if I'm in between somewhere along the curve, it would be less than that. It would be less than 2.5. And again, we're not representing it in 2.5. We're representing it in the percent of 2.5. So yeah, that's actually still looking fine. So it's 0.41, -0.41 of 2.5, which would make sense. And then you have the actual kilometers. Yeah. Yeah, and I got that by just doing the sine of it, because I had theta. I didn't need to do anything with it. If I wanted the kilometers, I would multiply it by it. So just cosine of theta, comma, sine of theta. Yeah. Okay, construct on the unit circle. Angles on the unit circle with these radian measures. Uh-oh. Angles on the unit circle with these radian measures. So I'll just... One, I could convert them to degrees and then just kind of know. Or I could calculate the x and y of each of them and then have a pretty good idea. I think I'll do the second one. Because these look like the side important common radian measures. Oh. Oh, actually, maybe it doesn't want me to do all of like that because it says to only do it for pi/6 here. Square these quarters. Well, if it's pi/2, it's 1/3 of that. So 1, 2, 3, right? Pi/2 divided by 3 times 3/1, right? Times 1/3. Yeah. Just pi/6, so 1/3 of it. 1, 2. I'd say here. 5 pi over 6. Well, if you have 3, oh no, 2, no, this is pi. This is pi over 2. Okay. Oh, yeah, I put pi over 6 as the construct angle on the unit circle. Yeah, I'd put it as the first 1/3 of the first quadrant. And then for 5 pi over 6, I'll just calculate it. So cosine 5 pi divided by 6. I get negative 0.86. Negative 0.86. That's kind of far. Negative 0.86. That's like here. Maybe it's in the middle. Okay, now let's do sine. Sine 5 pi over 6. 0.5. Yeah, so it is in the middle. Nice. So it's the middle of the 3. Pi over 6. 5 pi over 6. Alright, 7 pi over 6. Maybe like right here. Let's see. Cosine of 7 pi divided by 6. Negative 0.86. That's the same one. Oh, so maybe it's the middle, down in that third quadrant. Sine 5 pi. Oh, 7 pi. Did I do that for the last one? I put 7 pi, right? 7 pi divided by 6. Negative 0.5. Okay, let me just make sure. Okay, so it's halfway down. So it's just make sure. Cosine 7 pi divided by 6. Okay. So it's like here to the x, and then half. So it wasn't the first third, it was the second third of the third quadrant. Okay, we got 7 pi over 6. 1, 2, 3. Which of these would be? 11 pi over 6. Probably the last one. No, it should. Okay, so the unit circle seems like can be divided into pi over 6. And then 2 pi, so it would be 12 pi. So 2. Okay. I'm going to say the last one, but let's confirm cosine 11 pi divided by 6. 0.86. Okay. Actually, if it was... Okay. 0.86 and sine of 11 pi divided by 6. Negative 0.5. So it's the middle one, apparently. I should look up the unit circle real quick. Make sure I'm doing that right. Because if I find that the... Oh, it's not giving it in. Oh, here we go. Yeah, 7... Yeah. Huh. 7 pi over 6 is this first third one, not the second. And 5 pi over 6. Oh, I messed that up. I was doing some practice a few days ago, and I noted, actually it was with you, I think, with you guys, with you, and we were trying to derive stuff, and we found out that the y point is on either, it's on the 1/3 for the third coordinate, or the, oh, you can't see this. Anyway, I just misremembered that. 5 pi over 6 is here. because this is the 1/2. 7 pi over 6. Yes, this is the 1/2. Alright, so I should probably redo the other ones too. Pi over 6 was right. 7 pi. 11 pi over 6. Oh, what's the last one? Because half. Okay. Use your calculator to determine the coordinates corresponding to the angle with the measure of pi over 6. Cosine pi divided by 6. So let's see. So there's 12 pi over 6s to make up the whole unit circle. For one go around. Can't describe what these coordinates represent. 0.86. Sine pi divided by 6. 0.5. Describe what they represent. The x and y coordinate of the terminal rays endpoint. Oh, not endpoint. Just the x and y coordinate of the terminal rays. Not coordination. Intersection with the circle's circumference displayed in a proportion feels better, but percentage makes more sense. Percentage of a distance of 1. Okay, using the coordinates determined in part B, determine the coordinates that correspond to. Do not use. Oops. Oops. So how did they want me to do this? Because clearly I was only supposed to plug in this. I did it for construct angles of units. Get radian measures. Maybe I was supposed to convert it to degrees. I just kind of, yeah. Okay. Well, use coordinates to determine the coordinates that would correspond. Do nice. Well, we showed pi over 6 is at the same y as 5 pi over 6. 5 pi over 6 is at the same x as 7 pi over 6. 11 pi over 6 is at the same y as 7 pi over 6. And 11 pi over 6 is at the same x as pi over 6. So it forms a rectangle in the circle. Now, I clearly put that in wrong, but now that I see that, I already messed up C, but I'd probably say I have memorized the common radians and angles on the unit circle. Pi over 6 is at the same y here, but that wouldn't give you, it would give you the same x. It's funny, you would just put it minus. Oh, same x. And same here, you just do negative y. And you go, okay. Okay, so I would say, obviously, I have memorized the unit circle and know that pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 form a rectangle. I'm saying thus, but actually it's not clear making that connection. Like, I see it physically, but I don't get how having a rectangle, why each of the 4 points would then have the same coordinates. It's good. I know. What was that? Thus, quadrant 1 is x and y. Okay, yeah. Thus, quadrant 1 is xy. 2 is negative xy. 3 is negative x, negative y. And 4 is x, negative y. Yeah, I'm going to ask Professor how to show that since rectangle, xy's would be same, just negative / positive variations. Okay. Oh, on to the next one. I hope that didn't close out my recording. Oh, yep, still going. Okay. We just hit an hour. FPS is looking good. Okay. Yeah, there's a lot more work. There's a lot less workbooks than last week. I mean, section 1, which is nice. Well, actually, there might be a ton in week 4, but for week 3, it's pretty light. Oh, actually, well, that's not pages. Yeah. So we're on 7. What do we got? Yeah, we only got 4 pages, so not too shabby. And I'll probably just take a break, and then we're just with no notes, just attempting the homework. See how that goes. So, okay, let's run through this and then get a break going. So nothing counterclockwise. Label quantities on the diagram. They could be used to describe the position of the ball. Label quantities on the diagram that could be used to describe the position as it rotates around Jose's hand. Quantities. You could say position X, position Y on the ground. Like, you could have like a nail. Each of them are colored differently in a circle on the ground. And since it's perpendicular, like if you were looking right over, if you had another person look over his swinging, you could see, oh, at this point, it seems to go over this nail with a little red dot on top, and this one is purple, and this one is blue on top of the nail. So, simplify that, you would say, dash a marked position on the ground. Oh, I should say a marked positions on the ground that correspond to entire ball trajectory. could be used to describe the position of the ball. You could also say distance. Horizontally sounds weird because, yeah, you could say distance straight from Jose's hand. You could also say, don't say, x distance from Jose's hand. Y distance from Jose's hand. Define a formula for function f that relates the ball's vertical distance above Jose's hand in feet. Above sounds weird, but I know what they're saying. As a function of the angle of rotation measured rate as the ball swirls counterclockwise from 3. Be sure to define integer. She just signed, buddy. Actually, it'd be sine times. Okay, sine times the radius. You should define it into variables. Radius equals distance of ball at 3 o'clock from Jose's hand. That's defined. I should have the angle's rotation. I assume that angle of rotation is measured is already defined since they literally stated it, but okay. So F and it inputs theta equals sine of theta times radius. Yeah. Jose swirls the ball so that it travels 1 radius length per second along its circular path. What is the measure of the angle? What is the measure of the angle of rotation theta after t seconds? This is, okay, it's kind of fun. It seems to be combining from like week 1, like combining speed and distance with the 2 different functions into one, I think. What is... What is the measure of the angle of rotation theta after t seconds? Well, radius length is just radians. Like, as we said, the 1.1 radians is equal to an arc length of 1.1 radius lengths. So, and this would mean that in 6.28 seconds, it would travel the full thing, approximately. Because there's 6.28 radians in a full circle, one time around. What is the measure of angle of rotation theta after t seconds? Okay, let's write it down. 1 L or RL dash second. It just is the seconds. Because it's just, yeah, but formally it's theta equals, 1 RL per second times t, which is seconds. Because seconds would cross it, yeah. But since it's 1, it just is whatever t is. Yeah. Since 1 per sec, just t. Thus, theta equals t for seconds. Oh, theta is obviously not seconds, it's t. It sounds weird to say. Yeah, t radius equals t radians. A weird thing to say. Define a function g that relates the ball's vertical distance above Jose's hand as a function of the number of seconds elapsed. That's cool. Okay. We're getting somewhere. I like this. It's starting to actually build. Over what time interval? 6.28 seconds. Approximately. Find a function g that relates the ball's vertical distance above Jose's hand. Well, since theta is just vertical distance as a function, I wonder if it needs the vertical distance in feet, or if it doesn't mind it being in radius lengths. Okay, I'll just say, assuming vertical distance can be defined in radius lengths, I'll make it really clear, and I have to say, meaning it is not asked for in feet, then we should define in variables. All I need is, actually all you need is t seconds. It's cool. So you can just do sine of t. Yeah. Yeah, there's two. Equals vertical distance, open parenthesis, radius length. That's cool. Since t is exactly theta, then all you need is, and t is converting into theta and radians, and sine just takes radians. Okay. Suppose h rolls the ball so that it travels 2 radius lengths per second along its circular path. What is the measure of? Okay. Then it's just, let's see, we'll go back here. It's theta equals 2 RL per sec times t seconds. Yeah. Okay. Define a function h that relates the ball's vertical distance above sine of Jose's head and as a function of the number of seconds. Okay. Actually, I should have this right here. Well, now instead of just 1-to-1, you should define any variable. Yeah, so I'll just define, again, theta as 2 RL per second times t in seconds, and then function h, it's just h of theta, equals as a function of the number of seconds elapsed. Oh, as a function of the number of seconds elapsed, so I can't do theta. Oops. This is like that function of function stuff. Yeah, that's fine. Just h of t equals, okay, just keep this data, and then what I do to it, it's, I take the sine of it, the whole thing, function of the number of seconds elapsed, as a function of the number. Oh, so I wonder if I have to get rid of RL, and it's just 2t. Wait, no, it's not. It's t. It's 2 times t. Yeah. Oh, yeah. Because it's only in. Yeah, this one it was fine to say RL. This it's as a function of the number of seconds. So you can only have f of x. You can't have f of x, and also z in the function rule. So we'll just do theta. Doesn't make any sense anymore, but whatever. Theta equals 2 times t. Yeah. Okay, so h of t is just sine of 2t. Nice. And if I really wanted to get fancy, I could say, has g of x already been hitting it? I'll say d of, oh, that's derivative. I'll say x of f, x of x, r of x. Oh, well then, r of t. I have to get there. I mean, yeah. Over what time interval does the ball complete one revolution? It's just 6.28 divided by 2. 6.28. I can say 2 pi for exactness. Oh, so pi. Pi seconds, which is clearly pi seconds. That's 3.14 approximately. Over what time interval? 0 to 3.14 seconds. Yeah. Okay. First thing controls the ball so that it travels 0.5 radius lengths per second along its circular path. What is the measure of the angle of rotation? Theta equals 0.5 RL over S times t, open parentheses, seconds, defining it j of t equals 0.5 t, sine 0.5 of t. Okay. Over what time interval does the ball complete its 6.28 times 2? Why don't we give that? 6.28 times 5. 12.56. Well, it's 12.56 seconds. It says time interval, so 0. Okay. Oh boy. Graph function determined in exercises 3 through 5. One on each graph illustrated an interval of input values over which the function has complete 1 second interval of t for its ball. Yeah. Complete the value table values, and then graph G. See exercise 3. And then graph G. Complete the table. I can play. Oh boy, they. I like this one. It was bringing it together in a cool way. Okay, which one was G? Is it the first one? G. This is the one. One rate. Okay. So t is 0. Sine, yeah, 0. pi over 2 is also pi over 2. Pi, also pi. 3 pi over 2, 3 pi over 2, 2 pi. Okay, this is asking for one full cycle, but it has the table. Oh, you guys can't see that. It has the table go to 4 pi. Why? I put out much of that. Oh, maybe because 0.5. Yeah, that would make sense. Alright, this is 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. Okay. Actually, yeah, I'm going to graph this one. This seems interesting. Okay, so we got t and x. So we got 0, 0. But I'm only going to go to 2 pi for... yeah, I'm going to go to 2 pi. I'll do all of it. Okay. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Alright, you're going to make room for 8. I can do that. Pi over 2. Pi. 3 pi over 2. 2 pi. This is not to scale. Probably should have counted out which ones. Is it 5 pi over 2? Oh, interesting. So pi over 6 is 12 of them. And there's 1, 2, 3, 4. So pi over 2 is 1/4. Now, why is that the case? Because 4 pi over 2 in forms of half. Okay. 5 pi over 2. 3 pi. 7 pi over 2. And 4 pi. Okay. We got 0. Interesting. So in this one, the y is the same. So maybe I should label them in just radians instead of involving pi. Because the other ones are gonna... oh, well, I guess actually... that's weird to like have the vertical distance in pi. Yeah, let's do it in actual length. That means I have to calculate these. Shit. But, pi over 2. Wait, is this going to give me the actual... what was the radius? I don't even remember. 2.3 foot string. God damn it, Jose. 2.3 foot string. So if I wanted to calculate the actual height, I would make... you can't just make it 1, can you? Pi over 2 would be the radius in an actual. That means I have to calculate every single one. It's probably helpful for the learning. It probably is. Okay, so pi over 2 times 2.3. 3.61. Okay, well, what would 4 pi then be? I don't know, this isn't... I guess I'd have to do sine of pi over 2. Max vertical distance would be 2.3. Sine 2 pi. Oh. Sine of pi over 2. Pi divided by 2. 1 times 2.3, which could be 2.3. So the max is 2.3. Lower is 2.3. know if that holds for the later ones though. Oh, okay, so this one was 2 times, I think. H of t, h of t. H of t is 2 seconds per. So it just means it's faster. I don't think it means like, oh, this one has power of 4. Yeah, it completes it faster. So maybe it was, okay. Yeah, I don't think, yeah. Power of 4. 1.7 times 2.3. It would never be, yeah. Yeah. That's going to tell me down here the answer. But, yeah. Yeah, okay, so 2.3. Okay, so I'll divide it by, I don't know, 0.3 divided by, what, 4? 0.575. Okay. 0.575. What's that? The next one? 1.05. Okay, and third one. 1.7. No, 1.7. 1.15. Okay. 0.575 times 4. 2.3. Okay. There we go. That's not scale. This is negative 0.575. Negative 1.15. Negative 1.725. Negative 2.3. Okay. So 0 is at 0. Pi over 2's at... Oh. I did not think this... Oh yeah, I meant to... I can just do this on Desmos, I feel like. Maybe. Sine, let's see. Maybe just give me the values. Sine of x, and then times r, which is like the radius. Sine of x times 2.3. Okay, no, I'll just... Alright. Okay. Sine of pi over 2. Pi over 2 times 1 times 2. So, immediately at pi over 2, it's already at 2.3. At pi, it's at 0. Sine of pi, 0. This is a fast graph. This is only 1 per... Oh, 6.2. Okay, pi over 2, it's negative 1, so negative 2.3. Two pi, it's back at 0. I think this graph is crazy. Why is this graph crazy? Because it's times by 2.3. Because, yeah, isn't a usual sine, like, it takes, I think it's like in previous graphs, I've seen it be slower to make such dramatic peaks and troughs. 5 pi over 2 sine 5 pi divided by 2 is 1. Oh, okay, that's the... Okay, so I didn't need 3 pi, it's back to 0, 7 pi is negative 1. Okay, this is a very steep graph. Well, it's helping, but why is it steep? In fact, I thought like the later ones were going to be steeper. But this is just 1 per second. Because the radius is higher. So maybe it looks steeper. I thought it was okay. Sine graph. I guess it is that fast. Just felt like it. Maybe in previous graphs we've done in the workbook, it maybe did like pi over 6 or whatever the in between of pi over 2 and 0 is, and etc. And maybe that's why. Okay. Well, it's definitely taller, right? The amplitude is 2.3. I think I'm using that right. So that word. Okay, let's go on to the next graph. I really wish I had a screen for you guys. I apologize. I shouldn't say it's coming because that implies like a week or two. It's a little bit longer out to get that, but it is on my to-do list. Graph H. This is the 2 radius lengths. Okay, so sine. Oh, I have to do this again. H of t. What? So sine of 0 is just 0. This one goes to 2 pi. And 1 and 3 goes to 4 pi. Okay, so pi over 4, pi over 2, 3 pi, 4 pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. 2 pi. And the distance is... You know, it gave, I just realized, you know how I said in 3b, I was like, assuming vertical distance can be defined in radius lengths. in 2, it says vertical distance above Jose's hand in comma, open parentheses, in feet. So I probably should have assumed that it kept like it wanting in those units. So then all of these equations are the same except just multiply by the radius. Yeah. And yeah. mass for h, would the amplitude be 2.3 times 2? No, it's sine of 2t times 2.3. Does that make sense? Yeah, the speed of the ball doesn't change how far out you. Okay. Yeah, it's still the same. So I can reuse these y coordinates. That's nice. 5.75. That's my 1 hour, but we're so close that let's just blow through. 1.75. 1.15. Negative 5.575, negative 1.15, negative 1. These numbers do not make sense. 2. How is point times 2? Am I tripping balls? Oh. No, that's right. It really confused me for a second. That's too close. 1.15, 1.725, 2.3, negative 0.575, negative 1.15, negative 1.725, negative 2.3. Okay, and these are to 4 pi. So we got 0, pi over 2, pi, 3 pi over 2. So this is in increments of pi over 2, and this is in increments of pi over 4. Pi over 6 is less than that. Okay, so that's a little. 2 pi, 3 pi over 2, 3 pi. It's interesting how it just changes the increment. And it's 3 pi over 2, and that's 2 pi. And then it's 5 pi over 2, and it's 3 pi. That, oh no, it doesn't. 7 pi, 2. That's 4 pi. Okay. H of t, this is the 2 times, this is the 0.5, so 0, 0 times, still 0. Okay. Pi over 4, sine of pi divided by 4 is this 3.0. Oh, I have to multiply. It's sine of 2 times Jesus. Sine of 2 times the time. Okay, so sine pi over 4 times, I hope that messes up. Pi over 4 times 2 is 1, because it did pi over 2 pi over 4, which is pi. Oops. Okay. Pi divided by 4 is this, times 2. Okay, take a answer. Sine of, answer. Sine of answer, and we're in radians. 1. Pi over 4. Oh, times 2. Okay. And then times 2.3 is 2.3. So pi over 4, that's really quick. All the way up to 2.3. Pi over 2 then. Pi divided by 2 equals this, times 2, 3.14. Okay. Answer, okay, so sine of answer, 0. Oh, so even though it's, okay, so 0, so even though it's going more granular in its intervals, you know, pi over 4 versus just pi over 2, it's like going to the next one. So 3 pi over 4. That's not 3 pi. 3 pi over 4 would be half, but it's going to be at -1. Oh, there we go. -1, -2.3 pi. Interesting. Just make sure I'm on the right path. Okay. Sine 2 pi. Yeah, it would just be 0. That's crazy. So it just goes 2 point, and it's 5 pi over 4. Do I know pi? Yeah. Oh no, I guess that makes sense, because you would need to do 2 rotations into pi, and so 1 full rotation would be done at pi. Okay, so 2.3, then 0, then -2.3, and then 0. That's crazy. Okay, now this is half as slow. So 0 is going to be 0. Okay, so sine. Actually, just do. What's this? Pi 2. So we're down here now. I'll graph it in a sec. So pi divided by 2 times 0.5. And then take the sine of that answer. 0.5, yeah. 0.7 times 2.3. Yeah, because it's not as easy. Because this is that easy. Right. 1.62 is the distance at pi over 2. Oh, it's half as slow. So in 4 pi, it's going to do 1 rotation. So it's 1.62. So let's see. Pi times 2. Yeah, the next one is pi. Oh, it's pi times 0.5 is this. Take the sine of this answer, 1, and 2.3. Okay, so at 2 pi, I should be able to think this at, well, at 4 pi it's going to be 0. 1 point. Oh, 2 pi, it's going to be at 0. And 3 pi, it's going to be at negative 2.3. Now the middle ones, this is 3 pi over 2. Okay, so 3 pi over 2 equals this, times 0.5. Take the sine of that answer. We get 0.7, so it's going down. 0.7. This is 5 pi over 2. 5 pi divided by 2. I'll just calculate that. Okay, times 0.5. 3.92. Take the sine of that answer. Oh, did I just... Okay, 0.7. Can I multiply that by... Oops. Okay. Damn. 3 pi divided by 2. 2 pi divided by 2. Times 0.5. 2.3. Take the sine of that answer. It's points. Oh yeah, I didn't multiply it by 2.3. 1.62. Oh, it's back down to 1.62. Okay, 0. Now we got 5 pi over 2. 5 pi divided by 2. This times 0.5. This. Take the sine of that answer. Get negative 0.7. Then times that by 2.3. Negative 1.62. Okay, so it's just going to be negative 1.62 again. For 7 pi over 2. Let's see. 7 pi divided by 2. This times 0.5. 5 pi sine of that answer. This times 2.3. Negative 1.62. So yeah, you took... Okay, let's just compare that. So here it was 1 time. It was 1 time, 1 second per radius length. And there was 2 of them done in 4 pi. So just regular speed. Oh, I didn't even grab it. Oh. Okay. 0, 0, pi over 4, 2.3, pi over 2, 0, 3 pi over 4, negative 2.3, pi 0, 5 pi over 4 is 2.3, 3 pi over 2, 0, 7 pi is negative 2.3, back to 0. Okay. So in this one, there was 1 peak and 1 trough to 2 pi. This one. There's 1 peak, 1 trough before hitting 2 pi. This one, there was 2, which would make sense because it's 2 times as fast. this one is going to be half. So pi over 2 is 1.62. Where is that? It's like right below here. Okay, then of course there's 0. And there's pi, which is 2.3. And there's 3 pi over 2, which is 1.62. And there's 2 pi, which is 0. And you know what? Let's have some fun, I bet. Three pi over 2 is 1. Or 2 pi is 0. 3 pi. Oh, 5 pi over 2. 5 pi over 2 is negative 1.62. This is 3 pi. What's going on? Oh, I totally. 3 pi. What did I do here? 5 pi over 2. Yeah, and there's 3 pi. And there's 5 pi. Oh. I did not do this right. 3 pi, and there's 7 pi over 2. And there's 4 pi. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 4 pi. 3 pi, negative 2.3. 7 pi over 2, negative 1 pi here. Right here, and then 4 pi, back to 0. So it's very slow. Alright, I'm not going to read that yet. Okay, so we think we know what amplitude is, just how high and therefore how low it goes, which is defined by the radius. And how fast it goes through the circle, or whatever circle phenomena you're trying to model, how fast it goes through it, you know, what the speed of it is. Makes it more bunched. There's more peaks and troughs, or there's less per 2 pi. And why do we care? Why? I know we care for some reason. I know it's important. I don't know why. Okay. Time to get the magic answers. See what we got. The period of a function is the smallest interval of input values needed to complete one full cycle of output values. Not every function has a period. Makes sense? Functions with a period are called periodic functions. The amplitude of a periodic function represents half the difference between the function's maximum. Okay, so the amplitude would not be 2.3 times 2, which is 4.6. It would just be 2.3. It can be interpreted to be the radius of the circle in some length. We can write that down. I think that would be some notes. The period of a function is the smallest interval of input. Smallest input. Period is the smallest in. Oh, so one phone. So this period is pi, but this period is 4 pi, and this period is 2 pi. Let's see, I wonder if there's a way to easily find that out without graphing. Well, you see the 2t, 0.5t, or just t. So the indicator of maybe what's going on inside the side parentheses will give you a hint, or just is, then 2, and then if there's not a multiple, it's just t, or whatever we're looking at, that's just 2 pi. If there's a speed up of 2, then it'll be pi divided by 2. It'll get there in half as much time. If it's half as slow, then it just multiply 2 pi by 2. The period function is the smallest interval of input values. Needed to complete one full cycle of output values. Not every function has a period. Functions with a period are... I'm so immature. Periodic functions. The amplitude period of a periodic function represents of the difference between the function's maximum, parentheses, output positive, maximum and minimum output, parentheses, negative values. In the context of trig functions, amplitude in radius of circle. Radius equals 2.3 equals amplitude is 2.3. Okay, nice. One more page. Describe the reasoning used to determine the period of the functions in A, B, and C. Yeah, ask me already to. Okay, C, T. Period. Multiply / divide. Input coefficient in sign parentheses. Input multiply input in signs parentheses to regular period of 2 pi to get new period. What is the amplitude of the functions in part A through C? Okay, we already said. So this one just 2 pi. The next one is pi, and then it's 4 pi. Opposing controls the ball set travels 3.8 radius lengths per second. Changing the radius on this. What is the measure? Okay. The angle of rotation after t seconds. equals 3.8. No, theta equals 3.8. Yeah, 3.8 RL per second times t seconds. Yeah. Define a function k, the releasable variable has a function of the number of seconds. .8 radius lengths per second. Oh, interesting. It's not changing the radius, it's changing the radius length, which therefore means the speed. Define a function k that relates the ball's vertical distance as a function of the number. Okay. K of t equals it's actually just 3.8 or 3.8 t. I know I went back and I said, oh, it's actually just .8t times 2.3. Yeah. Oh, it's sine. Wait, I'm just. K T equals sine 3.8. T and then times 2.3, whatever the level of that sine is. Or for what time interval does the ball complete one revolution? It's 3.8 times as fast. I think. So, let me actually just. Here's okay, sine 3.8 times 1, let's put t as 1. So sine of 3.8 is negative 0.611. That's pretty far. It's like there, times 2.3. Negative 1.4. That's all the way over here in the third quadrant. Actually, potentially even in the fourth. So I'm pretty sure you just divide 2 pi by 3.8, right? Because with 0.5, that's what I would multiply it, 0.5 times 2 pi. And when we have the 2-second one, we divided. So when it's greater than 1, we divide, and when it's less than 1, we multiply. Here it's 3.8, so it's 2, is it? Yeah, it's 2 pi over 3.8. So 2 pi divided by 3.8 is 1.65. So if we plug that in, we would get 0, because it would have gone one full. Yeah, let's try that. Okay. Okay, so sine 3.8 times answer 0 times 2.30. So 2 pi divided by 3. I'll just rewrite it. 2 pi, because we're going to put seconds in that, but 2 pi over 3.8 seconds. For what time interval? Okay, 0 to that. What is the amplitude for function k? I hope I haven't been making that mistake. I think it's like, yeah, it's all 2.3. For function k, it's also 2. Oh, yeah, 2.3 feet. Suppose you determine that it takes the ball 20 seconds to complete 1 revolution. Determine the speed of the ball in radius lengths per second along its circular path. Good lord. Alright. Well, write it out. You can have, maybe you can, I feel like you can just do that. Was going to be really slow. How do you end up reading? Okay, so let's write it out. Just 20 seconds. I wonder if I should compute the circumference. Where is that circumference formula? 2 pi times radius. 2 pi times 2.3. Takes 20 seconds to travel this many, what is it, feet, I think. No, fucking, okay, yeah, let's, so 2 pi times 2.3 is 14. Okay, now 20 divided by that answer is 1.38. So it does 1.38 feet. Wait, I did not do that right. No, feet should be on the top. What the hell am I doing? Two pi times 2.3 feet over 20 seconds. Okay, close. 2.3 times 2 pi. Okay, that divided by 20. 0.72 feet per second. Radius lengths. I have it in feet, I want it in radius lengths. I wonder if I just... I feel like it's just point... What is the percentage of 0.722 out of Oh, yeah, maybe, yeah. Okay, so I hope it keeps it. 14.4513. 14.4513. Oh, I did that right. 19.999% times 5, because it's 1/20th. Because that kind of makes sense. So 19.9 radius lengths per. No, that does not make sense. Oh, 19%. So 0.199. 0.1999 radius length per second. Okay, so if I multiplied that by 2 pi, I should get the circumference. Now I should get 6.28. I multiply that. I multiply that by. Jesus Christ, I'm so lost. Like, I get where it wants me to go. I'm brain fried. God, how long is this recording been? Wow, 2 hours and 15 minutes. So I'm going to do this problem real quick with you guys still, but I know I said I'm going to take a break and then come back, but there's a part of the video I need to cut, and this is my first time doing it, so I don't want to pause and then keep going, because if I have to cut and I have to delete some part of the video, I don't want to lose the part that comes after this pause that's about to happen. Might sound like an excuse, but because we were supposed to start on the homework. But yeah. So let's finish up this problem. You know, I realized I probably should put this calculator over here now that we're done with this. Oh, I didn't pull this down for you guys. Okay, we're here. Seconds. .722 feet per second. What if I just convert units to make it radius length instead of feet? Alright, how would I do that? .722 feet up top, down below seconds. I want to change what's up top. So maybe I just multiply a ratio of feet, of radius lengths to feet. It's what? 1 foot is 1 foot is 1 out of 2. No, what? Oh, just 1 foot divided by 2.3. Or it's 43%. Sounds about right. So one radius. This is not. No, one radius length is 2.3. Okay, so 1 foot is 0.43 radius lengths. Okay, that sounds more right. Okay. 1 foot. Oh, but I want to cancel out feet. So 0.434 RL radius lengths is equal to 1 foot. Hope I'm doing that units. So apparently I just multiply across. Does that make sense? You got some amount feet per second. You're going to multiply it. Okay, let's see. Okay. Times 0.722. We get 0.31. Let's do the other way. 0.313. Now let's try it as 0.722 divided by 0.434. We get 1.66. Now let's see which one makes more sense. 0.313. Okay, 0.313. If it takes 1 radius length per second, that means in 6.2 seconds. Radius length per second. 6.28. It should do. If you multiply the radius length per second times 2 pi. Oh. For that, what would you get? You would get 2.3. One radius length times the amount of radius lengths there are in a whole circle would give you the radius. Oh, that might be rounding. Seems a little weird though. Okay. Okay, 1.66 times 6.28. That's a very weird number. I'm gonna go with 0.313. It's just for shits and giggles. 0.313 radius length per second times 20 seconds. 6.26. Okay, I feel like that is close to 6.28. One radius length per second. Because I calculated it at that speed, being 0.313. So the math kind of checks that if I'm multiplying it by the seconds that got me to that speed, it would give me one rotation. So that's a little reassuring. I'm going to definitely ask the professor, but I think that's a good answer. 0.313 radius length per second. Check with professor. B. Define a function m that relates ball's vertical distance as a function of the number of seconds elapsed. Well, now that I have radius lengths per second, actually I had feet per second. 0.313. Radius lengths per second. It's a tough one. I might want professor's help on B. Maybe I'm just tired. Function. Yeah, I'm definitely gonna end the video here, take a quick break, and then go do the homework attempt. And we have a professor's office hours tonight, so I'll check with them and let you guys know. Appreciate you hanging in there with me, and yeah, peace.